Okay, in this question, it's given that triangle ABC is similar to triangle DEF, and then it says find the length of DF. So as you can see, there is not a indicated length at DF. So just some information about similar triangles, some helpful information. Similar triangles are pairs of triangles that are exactly the same shape, but not necessarily the same size. So as you can see, these two triangles are the exact same shape, but they're definitely not the same size. Corresponding angles must have the same measure. So according to this, angle D would have the same measure as angle A. So angle D would have the same measure as angle A. You can see in the way that the triangles are listed, they're in the same place. And angle E would have the same measure as angle B. And angle C would have the same measure as angle F. So see, it's given that triangle ABC is similar to triangle DEF. Another thing that's interesting about similar triangles is the ratios of corresponding sides must be constant. That is, corresponding sides are proportional. So corresponding parts of similar triangles, or corresponding sides of similar triangles, are proportional. So that means they say, or they want you to find DF. Well, DF corresponds with AC. Now DF is not equal to 32 like AC is. It's proportional to 32. So we need a ratio that we can use here. Well, we have this side length EF, which is 8. Now the goal is find the side that EF corresponds to. Well, EF is going to correspond with BC. So EF corresponds with BC. That means this entire triangle, all the side lengths for these triangles, go with a ratio. So triangle ABC to triangle DEF, we set it up this way. So that means that EF, and I really should have put it the other way because I wanted to set it up the other way. It doesn't really matter actually, but I really wanted to put the triangle, the EF on top. So we'll do this triangle DEF to triangle ABC. So that means that EF to BC, which is 8 to 16, or 1/2 actually. So as you can see, each corresponding side length in triangle ABC is twice as long as each corresponding side length in triangle DEF. That's what's going to happen. Or you could think of it that each side length in DEF is 1/2 the length. So 8 is 1/2 of 16. So we can actually state, we could set up a proportion. Corresponding sides are proportional here. So we could say that EF is to BC as DF is to AC. So EF to BC is 8 to 16. We've already, seen that. So DF is going to be X. That's what we're trying to find. So X is to 32. Okay, so let's solve this proportion then by cross multiplying. So we're going to do 8 times 32 equal to 16x. So 8 times 32 is 256 equal to 16x. Divide by 16, and we actually get 16 equals x. So if 16 is equal to x, x is the length of side DF. Therefore, DF is equal to 16 units. And if you look at it, 16 is half of 32, just like 8 is half of 16. So these sides do follow the same ratio. DF equals 16.